Okay, our speaker today is, I hope I'm pronouncing it properly, Jean Martina.
Yeah.
Yeah. He's a professor at the Federal University of Santa Catarina in Brazil, specializing in information security, blockchain technology, and electronic documents. He has a PhD from Cambridge, where his research is in cryptographic protocols and secure execution of code. He's worked extensively on blockchain-based solutions, particularly in digital identity, electronic signatures, and regulatory compliance. And his recent work explores use of blockchain to improve transparency, security, and inclusivity in digital ecosystems, including its application of carbon markets and sustainable finance. And we're going to talk about work he did with Johan Westfall. So Thank you very much for coming. We look forward to your talk.
All right, thank you. Thanks for the invitation. It's always good to be back in Cambridge. And I'll be talking today about the work of Johan, that is a PhD student of mine. So as usual, as a professor, I only know it in average. Who knows it actually in real detail is Johan. So at the end, I think there is Johan's email on the slides, and I may make them available. So if you're interested in getting any of the details out of that, then you can reach Johan. So the idea here is that we're trying to devise to create a blockchain for an ETS model that takes into consideration geographical and time references. Okay, the idea is that we know where carbon is being mined or minted in this case into the blockchain, and when it happened. Okay, that is something that usually people don't care very much about, but what we are wanting to do in here, creating an idea of a social end on the carbon credits market, it is very important, because then people will be able to choose the timeline when carbon was synced in this case, and where it actually happened, because we want that it could be used by the local protein companies, the protein producing companies that sell all over the world, that they will use their, they try to offset whatever they are generating there locally, and not even inside Brazil. Brazil is a continent, so whenever we say carbon capturing in the Amazon, it's very difficult for you to see what that impacts in South Brazil, because we are 4,000 kilometers apart. So that's the way to have an idea. So this is just the structure of what will be presented. So what driven Johan's idea is not new to anyone in here, probably. So the need for change and action in this time with rising temperatures and so on, that are appearing with very complex weather and so on, that is changing people's lives. And then the Kyoto Protocol brings this idea of carbon credits, but there are some challenges, okay? Especially in terms of centralization and transparency. We have very few, at least in Brazil, we have very few companies that can do certification. And as usual, in there is corruption and high costs involved. Okay, and then what we wanted is to try to fit a blockchain solution into that, and as we are trying to do something that is very fine grained, then it seems to be something with a good potential. Okay, so the idea of what we've seen today, and that's why we're proposing another kind of blockchain-based ETS, is because we see that most of them, they do not have a good depth in terms of design. There is no interoperability. Whatever is done in one blockchain is stuck in there. And in our proposal, we have some ideas on how to chain different blockchains and make that interoperable. We also see that most of the proposals don't have a proper experimentation, and what we're doing there is trying to connect things for real and check with practical implementations what's going on. We also have concepts of privacy, okay, because the land will be owned by small farmers, okay, or family farming that, I don't know if you have anything to represent that in the UK, but it's like only a family that runs a very small property, and that we call that in Brazil family farming. Okay, it's just like a father, mother, a couple of sons, and they work the land as a way of subsistence, and then they sell the surplus, and that's very very common in certain rural areas in Brazil. And also we see that in case of blockchain specifically, there are performance issues. Sometimes people go to solutions that are not eco-friendly. So you're trying to save the environment, but then you use, I don't know, proof of work as a way of doing things. And also we see lack of regulation. So we are, and that's another thing that I learned here in Cambridge, is that if you want to make things go through, you need to go to policymakers. And that's basically what we're trying to do at this time in Brazil with this idea. We're going to our lawmakers and try to explain them what we want to do and how we want to use it to help enforce some of the regulations that are already in place. And also we have the idea that agricultures and rural lands, they have potential as carbon sinks, but we see that there is a lack of tech case studies for agricultural blockchains, and especially in this case of ETS. And what we've been seeing is that there are some ideas on coupling these blockchain systems with regulations and governance systems. We've seen a case specifically in Australia where they started doing that, coupling with a government database so that they can use an idea that is somewhat similar to ours, but then it's very applied to the Australian case, okay, that has a lot of differences between not only in the bio mass and the biosystem that is in there with ours, but also some of the ideas that we are bringing in that is not delivering all the carbon that was captured at once, or that is set to be captured at once as a certificate, as people usually do on the paper-based market, but we want to do it over time and using some interesting strategies to make people committed to that carbon sinking strategy. And we see that the idea of using space-time variables, they are important for carbon sinking, because you want to know where the carbon was sunk and also when. But these kind of things, the granularity that we see today is very large. So you say that it was sunk in Brazil and it was last year. We do not know exactly where in Brazil and specifically when. So that's what we are trying to bring in as a computational add up to the whole thing. Yeah, just have this. Close. So we did some research on that. Okay, we did a systematic mapping, and then we identified some research that is going there, and what we see is that there was lacking certain some of these ideas were not, that we wanted to introduce, were not in there. So what we want to propose in terms of our research is to incorporate spatial coordinates for every carbon credit that you have, and also a time window when it happened. And with that, we want to allow people not only to buy a certain amount of carbon credits, but choose where and when that carbon was sunk. That is a different idea.
So if I can question you,
Yeah,
on this,
yes.
do you want questions at the end? Or?
No, I think.
I mean, are you familiar with Vera and carbon credits from Vera?
Yes.
So Vera does tell you the location. The project coordinates are part of the Vera project description document, right? So you know the space, and they give you the coordinates, and then the time is when they do ex post credits, they'll tell you this is the time period. Typically, it's a 5-year period, but still there is a time period, right?
Yeah, I think the main thing that we are trying to do in here is to make that more fine grained. Okay, and also Vera projects tend to be very large properties because of the cost of producing that. And what we want to do in here is to introduce that idea of spatial coordinates and time in a more fine grain, but also work with small properties and try to help them protect. I'll come to that later, but I think it's important to enter in here. Brazil has a forest code that basically says that every property must have, I think it's 30 or 35% of the land mass on that should be protected. Okay, and especially in certain areas, it's even a bit more because that area is more endangered. And what happens is that people can do crops on the land, but they need to leave those 35% untouched. And what we see is that economic pressures on these small family farmers push them to try to invade that. And then sometimes they do a calculation where the fine is worth, because if you get in there and make it produce a bit more for you, the fine will be payable within a couple of years. And then you have another 20, 30 years to explore that piece of land. And what we want to introduce here is a system that will feed back into the local laws, the local legal system, so that people will get some money for something that they cannot touch. It belongs to them, but by law it's protected. So that's also another idea. So it's an incorporation of these two things.
Okay.
And then what we are trying to bring in here so is an increased trust on these government databases. And to make this even more interesting, the government database has a time when it was last updated, and we use that as a multiplier that weights the credits according to some specific policies that we can implement for certain areas that needs more or less protection. And then by doing so in a blockchain and having everything in there, we have a very broad policymaking strategy, and we have a lot of transparency. Okay, so Johan did basically a whole literature review in that with systematic mapping and so on, and then we ended up proposing this ETS framework, blockchain ETS framework, and we focus on rural land carbon credits and RED projects. So here, I don't know how many, I brought these in because I didn't know the background of everybody. Everybody knows about blockchain. Otherwise it can go.
I teach a course here about this, so I do know something about it.
No, but well, I'll go very quickly because what I want in here is to introduce you to blockchain. But then I had a slide so that we can be on the same page, understanding what's important for us at the moment. So basically, a blockchain is a decentralized and immutable ledger, okay, that usually enables secure and transparent transactions. And the idea is that you get that ledger, similar of a ledger book that we are used for millennia in humankind. But it is digital and it is decentralized and it has the property of being immutable. And this is shared among the multiple nodes that will be using the blockchain. And then what we do, we use cryptography in order to group and relate blocks. And we use public key cryptography so that we can know who actually created each transaction. And it is a distributed and decentralized solution in nature that has usually the properties. You always deploy, you should always deploy blockchain technology when you need things like immutability or transparency and tamper proofing. And what we have in there is also the capability of programming of a programming language where we can actually create a program that runs on top of this blockchain that we call smart contract that has automation. It defines the rules for execution, and we need no one to call it to run. It runs on itself. So I'm just briefing people on what's blockchain, okay, so that it's okay. In order to decide what goes on a blockchain, what we have is some consensus algorithms. So we agree that that is being modified in a certain way. We have the concept of public blockchains and private blockchains. We call them permission and permissionless. So depending on the case of the application that we are deploying, it may be interesting to use one or the other. Okay. We also have in this blockchain technology these days things called zero knowledge proofs that are ways to introduce very strong privacy requirements whenever you need to prove that something was already on the blockchain. And we also have another concept in there because you can track and trace whatever is inside the blockchain, or we call it on-chain, very easily. But whenever you get something from outside, from the real world, or you output to the real world, we have what we call an oracle, okay, that will give us the information or take the information out and put somewhere else. And this is basically the technology that is behind, okay, that we'll be using for blockchain. We have different platforms. Maybe people, if you turn on the TV and watch TV for a couple hours, you hear the word Bitcoin. It's very likely. But what we are interested in is not specifically on the monetary value of how much it's worth of Bitcoin, but on the technology that is behind. So we have some platforms and specifically some platforms that bring smart contracts to them. Specifically, we looked to certain ones. I will not come into that, but each one of these platforms have different capabilities, and Johan surveyed Ethereum, Hyperledger Fabric, Cosmos, and a couple others. And what he realized is that our idea is independent of the blockchain technology itself, but some of them will fit better depending on the scenario that it will be applied. Another thing that we have is the possibility of what we call cross-chain communication, because whenever you choose one of these technologies, maybe someone else has chosen another. Okay, and a big challenge that we have is how do we create something in one of these technologies and interoperate with another's. And then we have what we call cross-chain communication. That is a strategy where we could go and create a system of carbon credits that runs in any of one of these technologies, but it will have to interoperate with others, because people would create systems either to negotiate or to destroy the credits in certain scenarios using other technology. So for that, we looked for schemes based on notary schemes or relay chains and side chains. These are only ways of connecting the different blockchains so that we can run everything in one blockchain, but be interoperable with any other. Then carbon markets, I think most of you are aware, so I'll go very fast in here. So this is the mechanism for trading carbon credits that are representing units of carbon emission reduction. These came from Kyoto Protocol that now is going down, but yeah, when Johan started, it was all fine. There are two main methods for generating carbon credits, either emission allocation or carbon offsetting. Carbon markets can be mandatory or voluntary, depending on government regulations. And offset projects are rated by performance, leakage, and additionality. Okay, that's the basic idea. And in here, we bring a picture that is on Johan's paper that he's working right now. That is basically explaining what's the difference when you get this idea of carbon markets and you attach them to blockchain. Okay, so in the current centralized systems that use usually the paper-based ones that we see these days, you have some way of doing either performance, leakage, or additionality and measuring that, and then you get your carbon credits issued. Then you have a broker that will sell that to a customer, and that customer will have those credits to offset in the situation that he's in. On blockchain systems, of course, this lack of transparency is because we have to trust auditors and that everything is going on in accordance to the regulations. Whenever we get blockchain, we can get data, and we use the data to prove and to verify and to automate this whole credit issuance. And then once the credit is issued, it can go straight to the customer. We don't have a middleman. We don't have the broker. Maybe that's one of the things of using blockchain technology, is cutting the middleman. And then you get the customer. And in our case, we have the retirement of that carbon credit is also recorded. So we know when it was created and when it was retired from the market. That is one thing that can also be automated in certain cases.
I mean, you said there's no proof of retirement. There are retirement websites and so on where people retire credits. That's how they prove that they're offset, right?
Yes, but again, there are websites, but there is no interoperability. There is no way of you following the life of that credit in a very easy manner, I would say, like checking what was created and how it was offset.
I mean, I've seen these websites myself, and it's very clear to tell you this particular credit was bought on this date, was sold, and it was retired in this date, by this particular purchaser, etc. That's all very carefully recorded. At least you do Vera credits. I don't know about others.
Yeah. Maybe what we are trying to tell in here is that on these centralized systems, each one of these systems goes in one way, and they don't care very much about interoperability.
Right, but 90% are Vera. So the other players, American Carbon Credits and Plan Vivo, are less than 10%. So if you believe in Vera, which I don't, but nevertheless,
Yes.
there is a central location which does record these things. Otherwise,
yeah, they do live forever.
Yeah,
right.
Yeah, I mean, so exactly. So this is even the Kyoto bureaucrats realize you have to retire it and have to be careful about that. So I think that statement of no proof of retirement is a bit strong.
But I think the 90% is both their and gold standard.
Right.
Together they have 90%.
That's right.
And gold standard, I can understand where Vera is very clear, but gold standard has their own separate total system. So 90% are two different parallel universes, maybe.
Yeah.
Fair, but I mean, they both do have retirement.
They do have retirement.
So I mean, it's not, there's no proof of retirement at all. I stand corrected.
Okay.
John knows it much better than I do.
All right.
Yes, that's the question.
Yeah.
Can I ask quickly, what information here would be publicly recorded on the blockchain, visible to everyone, and what remains private?
Yeah, we'll come.
Okay.
I will bring some details later, but the idea here, Martin, is that we'll be recording when and where and how much was actually created, how the carbon credits are issued with that, and we track all that for every credit until we have this retirement that is also recorded on the same chain. So you can always call for a credit and know that it is already retired. So you never be able to buy a retired credit. And maybe I think what Johan was trying to say in here is that we have issues with double spending and or double selling of these credits that of course the markets are getting more mature these days, so we're seeing ever less of these, but at the same time it happened a lot in the past, so people are a bit afraid on these markets. And with this kind of tracing of what's going on with the credits, you're ever sure that whenever you're buying, you're not buying something that is already spent, that was already retired. Okay, and then we have in Brazil now a carbon market. Okay, it's a law that was approved now in 2024. It created the Brazilian Emission Exchange System, and it allocates it does allocation and offset credits, and then we have this our own names for these that are in Portuguese, and they provide definitions and encompasses many stakeholders. So we have the carbon capture projects, the project verifiers, the verification methodology.
Gina, I'm just trying to understand, what is allocate, what's an allocation and what's an, I know offsets, but is an allocation, the credit side of an offset?
Yes.
So it's saying that there's some climate benefit, as a result of some intervention?
Yes, yes. So, for example, in terms of allocation, we have things that are really done in such a way that prevents something of going out. That is basically what we are trying to do in here, is not offsetting, is allocation. Because we have, for example, Atlantic forest in South Brazil, and it's very, very endangered.
Yeah.
So what we do, we do, instead of doing offsetting on the carbon credits, we do this allocation so that we'll try to help people not to take these forests down anymore.
And so what exactly is allocation? What is 1 unit of allocation? What does that mean?
Sorry?
So what is allocation? I'm trying to say what.
Yeah, what happens is that I get this bit of forest that is already in there,
Yeah.
okay? And then I do not touch it. So I allocate that as something that would not be taken down, so that this carbon will not be released.
Got it. So it's, you're still measuring the additionality of that land.
Yes.
If it's under danger. So it's a measurement against a counterfactual,
Yes, yes,
as opposed to just buying the land.
yes.
Right, got it. So it's a carbon credit in that sense.
Yes, it's a carbon credit.
Okay.
Okay, but we separate them in offsetting. Okay, so you're basically creating, you get like land that is bare, and then you planting trees. That's one thing of offsetting, that's capturing.
Yeah.
But then you have land, and that's most of the case of Brazil. Basically, what you have, you still have forest in place.
Mhm.
And what we want is not to be planting more forest. We want to save the forest that is in there. And that's what allocation is about. It's different than offsetting.
Right, got it. But that's the classic definition of carbon credit, right? Which is separate from offsetting. So carbon credits are some additional intervention
Yeah.
that's adjusted
Yeah.
for leakage and permanence. And then you're measuring that climate benefit for that
Yes.
individual action. That's brilliant. Thanks.
And then the law brings also many stakeholders, as seen in here. So we have emission quotas, burning and carbon certificates, emitting companies, verification methodologies. Everything is brought in that law, and I think, if I'm not mistaken, it's based in somewhere else's law. Okay, and it foresees international interoperation, and that's why it's similar to other places. Okay, and then it's the UN compliant. Then in order to move on of what we want to do, I need to tell you a bit about our land parcel identification systems. Okay, so our forest code that came before this law required Brazil to register and control all rural properties in the country. Okay, and what basically the government did was to get high resolution spatial data about land use, and they created this CAR, that is a rural registry, rural land and environmental registry, which registered all the properties, and also does use this satellite imagery to actually check how much of that land is separated to be used as this protection buffer that every property has to have. And it varies again with other things. It's not that it's 30%. For example, if you have some body of water in there, then whatever is around, you need to protect, if I'm not mistaken, it's 20 meters from any border of water needs to have a forest. If it's a river, it's a bit more, okay, to protect the shore banks and so on. And all that is in this registry. It is the states in Brazil, each state is responsible for that registry, but then we have a national system that agglutinates everything in this big database that has the the satellite imagery, but also detail verification that was done in place with boots on the ground, going there and actually checking. So in Brazil use that to control how things are going. So every 5 years, I think, by law, they need to get new satellite imagery and check how everybody is doing. And if someone took off part of those protected lands, then they go there and find people. And that's basically it. And the problem is that it happens a lot. Okay. And the kind of thing is that even the law is complicated because of how the political system works in Brazil. So these very big farmers, they have a lot of power and they elect a lot of people to the lower and higher chamber. So it's very difficult to pass a law in Brazil that will actually make this punishment worth. So for guys that are on the soybean production business, it's basically impossible to find them with something that would hurt them. Okay, because they make so much money.
And just we have about 20 minutes left
Yeah.
before you leave the room, so this.
Okay, so this is one database that we are using, but there are quite so many others. Okay, so we have map biomas, that is vegetation type and land use. We have Embrapa, that is our agricultural company, state-owned agricultural company that has raw data and a lot of studies. We have INPE, that is the Brazilian space agency, and they have a lot of satellite imagery. We have also INMET with meteorological data and a big network of meteorological stations. And then we have this CJAF, where we have georeference rural property data, including the certifications that they have. Okay, and I'll go.
These databases, are they all Brazil or is that?
Yeah, no, they are all in Brazil. But what you want to bring in here is that we are not using only one source. And these different sources, they give us different confirmation on what's going on and different levels of assurance. I will skip how Johan got onto the ideas. Okay, I'll make this available later, and I'll talk as we have only 20 minutes. How the model that he is proposing is what we are implementing in fact, okay, and what we are trying to go to the policymakers in Brazil and try to make them understand in such a way that maybe this could go live, at least in Brazil. So we created a segmented a model that is segmented into some configurable modules. Okay, so we have the blockchain network itself that maybe is not the most interesting part because it can be changed for other technological apparatus in there. But what we have is this idea of these data sources and oracles that will be telling us what's going on in the real world. Then we have a module that is for minting and burning the policies themselves. So we say how much should be minted in that specific situation with different multipliers depending on which database or the level of assurance that we have on the input data coming from the oracles, and also the burning policies, okay, that can be variable as well. We have then an auction system, okay, where people can go there and negotiate these credits. We have a credit burning infrastructure, and we have what we call cross-chain interoperability, because the credits that we are aiming to produce in there, they can be bought and sold in different platforms, okay, but everything is tracked down to the platform where we are doing the things. So this is the conceptual model that Johan came up with. So I will start probably with we start with those technical committee that will define and update methodologies and policies so that we know how much carbon credit will be produced depending on the kind of data and the amount of time that and the assurance that we have on that data. And once we have that, it will influence a multiplier, and this multiplier will weight either credit mining or credit burning. So the idea is that these policies will be embedded, whatever is inside that bigger square, dotted line square, it's the system itself, okay? Then we have credit minting, and we get these data like other sources in this government database as sync data, and with that we create the carbon credits themselves. And we have the same thing about credit burning, okay? We have weights, and we have the emission data that comes from government databases or other sources. Everything can be audited, especially on the sync data and the emission data, as we have on usual systems. And this multiplier will influence the amount of credits that are generated over time. And as I said, one of the things that we are not doing is going to a project and seeing that project and say, okay, this will capture that amount of carbon for 5 years. Take your certificate, and then we flood the market with a lot of carbon in that sense. What we have in here is the idea that we'll be producing it slowly over time, and we'll be giving it to people slowly over time. And yeah, it can be audited, externally audited. And then we have this cross-chain interface where that carbon credit can be also negotiated outside this blockchain infrastructure. Okay.
So yeah, I don't quite see, where does time come into this then? So let's say you're doing some analysis ex post. So you're verifying predetermined projects, that's good. But in this, I guess I don't kind of see the point of a blockchain at all here. Why can't a government database do this? Because then you could trivially just say every year we'll reassess projects and issue new credits and stuff, right? Whereas if you do on a blockchain, you then need to have a notion of time to say that, you know, these contracts and these distributed systems will tick.
Yeah, yes. What we are trying to do in here is because all these data sources, they are updated with different timeframes and within different branches of government.
Yeah.
And the problem with that is if this is going to be somewhere in the government, it has to take one specific spot, and then government has its own bureaucracy to access in government things. And I think the idea here is because we are trying to bring information from different oracles and merge them in a certain place. Could we do it with a database? Probably yes, but it only could be done by the government themselves because they can issue a law that says that they have authority over that information. And that's it. But if you are...
That kind of ties to Martin's question, right? Because if all the data is public, then anyone can do that. Anyone could run one database, right? But if it's private, then I don't see how you could put it in a blockchain. Yeah, I guess you could put it in a permission one.
Yes. The idea here is that it is permission, okay?
It is permission. Okay.
Yeah, it's permission. It's a permission blockchain.
Got it.
Okay, so we're... So we can have the oracles feeding in information, and you have a history on how the information came from a certain database and how it was changed in the database. The problem of using a database itself is that maybe the database is changed and you may lose the information on how it was before. And as we are trying to calculate the differences between things, so having this history ends up being important. So that's one of the reasons why we went for blockchain, because in order to reproduce that with databases, it could be tempered with, and that was one of the things that we thought. Of course, technology-wise, it will be much simpler, okay? It will cost much less and so on. But we are a blockchain group, so we have a hammer and we are finding a nail. That's it. Okay, that's
I definitely believe that.
It needs to be a PhD in computer science. So
Yes, absolutely.
Yeah, but I think there's another angle to that question. I mean, maybe in other kind of use cases, you see problems with local government databases that have had issues? Is that, is that something that you see has been? prevalent?
Yes,
Possibly,
so
maybe with the cadastral data or some other places,
Yeah, that-
maybe, right?
in the environmental side, maybe not, but we've seen that Latin America is a very peculiar place in terms of how governments, changing government can change everything,
Right, right.
okay? And even history.
Yep.
And that's one of the problems. So if you leave for the government to tell history, they will try to rewrite it.
So really, it's not that you don't trust government, you don't trust the succession of governments to record history accurately.
It's a bit more, we do not trust governments, but we trust even less when they change, because whoever comes later will try to rewrite history of what happened before.
Right.
And if we do not keep track of those things, we are very new into this environmental part, but we've seen this happening on social care. We've seen this happening on other government spaces inside, like not only Brazil. We can talk much clearer about Brazil, but I've been working a lot in Latin America, and this happens probably even more than Brazil in other Latin American countries.
Yeah.
Okay, so maybe it doesn't make sense because the reality there is slightly different
No,
than it is in here.
without arguing, I'm completely convinced by the use of a permission blockchain with that specific problem in mind. Because otherwise it does seem that there's no other answer, right? You need some way to, independently of the government infrastructure, to record the fact that history has been rewritten.
Yeah,
And yet keep it around for when the next government might want to bring this one back. That seems entirely viable to me.
Yeah. so we have then, Johan has defined this, let me just check, okay, 12 minutes. Then I'll try to be quick. So he defined these minting and burning policies. So these are defined and updated by a technical committee. So we're not trying to sort out the problem that needs to be sorted out by the people from the biology part or the land economy part. Okay, we are focused on the computer science problem in here. So whatever they decide, we can implement. The idea is that we turn that data that comes from the database into carbon credits using multipliers, and these multipliers are defined by this technical committee. So, for example, if SICAR was updated last year, then we may mint 100% of credits. But after 2 years, we only mint 80%. And there you go. So you have something that will tell you to go to the government and ask them to come and visit your property so that they update the database so that you can mint more credits. Credits are minted periodically. So we've been doing tests. We can do it daily or weekly or monthly or every 5 years, as everybody does. But the idea here is that it can be done at a finer grain and it doesn't impact how we produce the carbon credits. So we have independent policies that can be applied at the edges of all that. So we have a general policy, but then suppose that we want the government in there would want to enforce a stronger policy in a certain place. They can use this monetary influence of paying some credits to these people and force a larger multiplier so that they will receive a bit more in that specific space. And also, we coupled policies. Minting and burning can be coupled. So whatever you are emitting, you need to buy that, and you can get the same thing. So if you are in a certain area, I can go and have a larger multiplier on your emission so that you need to buy more credits. And also we were thinking on the geographical capability as well, because if I'm in South Brazil and I want to buy credits from the Amazon area, okay, maybe I'm offsetting too far away from where I'm actually emitting. And with that, we will be able to actually come to that because we have this geo reference on every single credit that is issued. We have then the auction model. It is also affected by the policy, but I'll not come into that because auctioning is just how you put sinking and emitting on the same context. Okay. We have some parts of the action, the auction can be run off chain, okay, to preserve financial privacy, okay, if you're buying and selling. But also we can do zero knowledge proofs or transparent encryption, okay, to separate chains from auctioneers. And Johan has also been working on that. And it's a very interesting strategy whenever you want to protect privacy of whoever is buying or whoever is selling. Okay, and it's already embedded on the blockchain strategy that he's using. We have then this cross-chain strategy that is this is a standard in cryptocurrencies market. So we've been seeing those tokens that are based on currencies, actual currencies. So we have like USDT, for example. It runs, it's a US dollar tether. It runs on a specific chain, but you can buy and sell it on different chains because they have this cross-chain interoperability, and everybody is registered at one specific place, but can be negotiated on different spaces. So that's basically the strategy that Johan is trying to do. And to come to an end, because all the rest of the slides are just the reference that has been put in here. So what is the uniqueness of the approach that we are trying to bring? Some of them are computer science. Some of them has regards to the specifics of Brazilian regulation. Okay, so it enables vast data types and sources. We bring in a lot of different data types and data sources, and we bring them with space-time as a factor. So from the data, we check the database when it was last updated, and then we know how to apply space-time factor so that we know how much that influences on the carbon minting strategy or the carbon burning strategy. It's also a modular architecture, so we have independent and coupled policies. So we may have things that works together on emitting and sinking, but also it can be completely detached. And the policies, as we thought, they would be defined by the technical committee that knows how the environmental part actually works. The auction algorithm maximizes sinking based on the multiplier, and it's linked with legislation. Okay, so we are trying to bring trusted public governmental databases and some external ones to verify if the government database is correct or not. And it's inspired by what's on Brazilian law that was passed last year. What we see in here is that it may be applied to other places because with this cross-chain strategy, maybe we can put those credits in other blockchains that may happen in other countries. Okay, and I think what I can tell you on that is that we are producing now a document that we are sending to Brazil's parliament to try to convince them to come with regulation to bring this strategy as a nationwide strategy run by policy. Okay, so yeah, so here is what Johan is implementing. Okay, so the technologies that he is doing now, he's actually working with, and the conclusions are that it tried to address some state-of-the-art challenges because we've been through literature and tried to find, but again, maybe you are much more on the environmental side, and as I said before, he needs to get a PhD in computer science, so we are trying to focus on the computer science problems. And basically we had this idea of proposing a country agnostic bets model for regulated markets, but it's inspired on the Brazilian specificities. Okay, and yeah, for future work, then Johan is planning to make it even more private and even more transactable. Okay, and I want to give you time for, and there are the references. I can send you later the slides. Okay, and then we have 5 minutes for questions.
Thank you.
Thank you.
Yeah, anybody with? Yeah, I think maybe going back to what I asked earlier, so still didn't quite understand exactly what information is now actually public on the blockchain, what is not. So you mentioned that there's information from government databases. Is that like geospatial?
Yes.
Land use information? Is
Let me try to find here. Oh, crap. Um, so we have let me check if this will work. We have basically a website with where all this data is in. That is let me find the open public access database. For you to have an idea what is the data, this is the main database where the forest code in Brazil is actually monitored. And within this specific system, we have every single property in Brazil is mapped and georeferenced and has a unique identifier. And in there you have a map of what are the protected areas with geographic information on that, the amount, the type of biome that it's inserted, and any kind of features that are important for that. And what we are doing, we are acquiring that data. This is public access data, if it runs, okay? But it's publicly available data. And we are crossing that with other databases that are just from within the government, okay? That is not public data. But because UFSC is a federal university, we are part of the government, then we can ask for access to those sources. And we are also talking to certain companies that they have data because they work on that. Oh, it's loading. It's just slow.
But all of this data essentially comes down to a single number, right? The number of issued credits for a particular project. And,
Yes.
And that number is the only thing you need to transact on the blockchain. You need to add and subtract from that number.
Sort of, because we can add more features depending. Let me try to get here.
Are there any more features than just that? I mean, it's literally the number of tons of carbon credits issued, and you want that to get to zero, and you want to make sure it's not double counted, right?
Yes, but what we are doing, and we are actually getting to a not only that, we are tracking where, when, and from which source did we get that information from, and how do we trust that information? How
And
trustable?
That's on the blockchain as well.
Yes.
Okay.
So let me try to get one of these. Come on.
So these are land ownership records, yeah?
Yes, these are land ownership records. And then whenever you click one of these, it should work out in here.
And this is uniquely Brazilian, right? Like this level of land recording I've not seen in other countries.
Yeah.
This particular thing seems really interesting for this use case.
Yeah, I don't know why it's not loading, but it has you can get in here, and then it brings to you the whole area, specifically the coordinates. And when you go inside one of these specific squares in here, then it shows you exactly where is the protected part, which features do you have. So you have like a creek, then there is that also recorded because it was done with satellite imagery, but also with boot on the ground. So people went in there to check what was going on. So I think I can.
Is this database public or private?
This database is public.
It's public. So what's private then?
What's private are the other databases that comes from the space agency, from the biomas, because then we have our agricultural state-owned company that goes there and say, okay, this biome in here is Atlantic forest, and it's in this specific region. So they have a description of which kind of trees happening there, which kind of fauna and flora and everything. So it's very, very detailed. And what we are doing, we are tapping into that to know, for example, maybe I want to give a multiplier because there is a specific kind of monkey that lives in that specific shape that I want to protect. So I put a multiplier on that. I give a bit more money for people keeping away from that. And that's the granularity that we are.
And that's the kind of zero knowledge proof that you want. You want to have proof that there is something that tells you that a monkey might be living there, so that someone can verify why you just added all.
Yes.
Right, that's interesting.
So the idea here, again, maybe I agree with you that blockchain may be a gimmick on all that, but what we are trying to do is to add much more information than just the standard, go there are that many number of trees, and then I certify a big piece of land. And the other things that we are trying to convince Brazil's government is that instead of certifying property by property, they could go there and certify, for example, a whole valley. And then each one of these properties will join the scheme on their will and say, okay, I want to get some money for the carbon credits that I have in here. And my area is pre-certified. So I just go there and join, and then I start having an account that people will be dropping some cents every day or every month. I don't know how it will work.
Data from the different sources, are they in the same format? Do you need to?
No, they are in different formats.
So then who's responsible for converting things such that they?
This is done on chain. This is done on chain. Okay,
Done
so
on chain.
yeah, it's done on chain because what we know is basically georeference of that information. So if we see that these two things are one on the top of the other, so we believe that the database, we believe because it may not be true, okay, but we believe that they talk about the same space, and then we can understand that we can mix this data from one source and another, but that's done on chain. We acquire the data.
How does that help? What if I just?
Actually, can I just take it? Let's thank Jean and then.
No, absolutely.
Yeah.
So I think some of us have other meetings to go to, and here.